Hello and welcome. Let's try to solve another Leetcode problem. 1397, find all good strings. So for this example, we are giving strings of s1 and s2. So they both have length of n, so the size is n. And for this example, the size is 2. And we are also giving a string eval. So the eval can be any length, so the longest is going to be 15. Yeah, so this is going to be the eval. So we're going to return the number of good strings. So what is good strings? It is of size n, of course, and alphabetically greater than or equal to s1, and alphabetically smaller or equal to s2. And it does not contain the string eval. Yeah, so this is also easy to understand. I mean, everything is easy to understand because it's never going to be so big. So finally, we're going to return a modular of 10 to the power plus 7. Yeah, but this is going to be a really hard problem. Let's also check what we are giving, s1 and s2. The length is going to be 500, and the eval going to be 50. Yeah, so maybe the time complexity going to be 50 times 500, or maybe it's like that. Yeah. But if we are giving something s1 and s2, we are going to count how many strings of s2 between s1 and s2 alphabetically. So basically, this is going to be a digit DP problem. So for digit DP problem, normally we're going to have a template for the digit DP. And secondly, because we need to avoid such kind of eval, so this is a string matching problem. So this is we can use a KMP to solve the string matching problem. So yeah, basically we need to use two templates. So one template is digit DP, another template is KMP. Yeah, and at the same time, inside of the digit DP, basically it is a dynamic programming, and we need to find the eval, and we need to try to avoid the eval string. Yeah. Yeah. Now let's just start. Start doing it. I think for solving this problem, basically you need to know what is a digit DP. You need to be very familiar with how to write a digit DP and how to write KMP. Basically, they are both templates. Actually, you don't need to think about it because they are all about the templates. Yeah. So first, let's just try to write some digit DP. But for this digit DP, first of all, let's just avoid this eval because this is too hard. Let's first write a digit DP. It's gonna be find all the strings between s1 and s2, but we will ignore this eval because this is easy to write. Yeah. We're gonna define f function for the DFS with memorization. So we're gonna prepare an index I. So I gonna be start from 0, and we're gonna prepare its limit. Yeah. So this its limit is to control the characters. So for example, the first character is A to D. So while it goes to D, so this is gonna be a limit. Yeah. But if it is the character A, it is not the limit. It means for the next character, we can choose from A to Z. We can choose all. But if the first character is D, the next character we have to choose A. So this is why we prepare its limit. Let me just finish writing it. Yeah, so here we're gonna prepare a string. So this string is gonna be passed from s1 or s2. Yeah, because basically we need s1 or s2 to control it. Yeah. So if I equal to the length of the string, basically we can return a 1. Now we're gonna prepare the result. So the result is gonna be start from 0. And then we're gonna prepare the high. Yeah, because for the digit DP, so for example, this is S2, we passed into this string S. So we want to find all the characters which equal to the length of 2, and it is less than or equal to S2. Yeah, so this is what we are doing. So we just need to prepare a high. Because this high is determined by its limit. So high is going to be as high if its limit. Otherwise, the high is going to be Z, because there are 26 characters and Z is going to be the highest characters. Now we're going to use a for loop. So for any digit in range, yeah, or we can use another way. Maybe let me directly use a character. So for C in ASCII, ASCII and lowercase. Yeah. So this is going to be all the characters. Yeah, it can be any character from A to Z. Yeah. So in this way, we don't need to turn some integers to characters. Currently, this is our character. Yeah. So if C is less than or equal to the high, so we're gonna update it to our final result. It's gonna be fi plus 1, and its limit, we're gonna use the its limit, and we're gonna check this character if it is equal to the high or not. Yeah. And we're gonna put the string inside. Finally, we're gonna return this string. Yeah. Now let me just give a random return to check what it is. Yeah. So we're gonna pass the 0, its limit to true, and s2, and we're gonna minus with 0 to true, and s1 plus 1. Yeah. I just want to check if this digit TP is right, because basically it is a lot of coding. If you are write some program, you need to check if it works first. Yeah. Yeah, because definitely you don't want to try to write some more than 30 lines of code and then you're gonna check, because it's really difficult to debug. So currently, if we find something wrong, definitely we're gonna fix it from here instead of the whole program. Yeah. Yeah, you know, there's something wrong. Yeah. So here the problem is coming from the integer and the string. For plus equal to integer and the string. Yeah. Here this is the integer for the result. If I equal to that. Yeah, let me maybe write it like this way. So for D in range from 97 to odd. Yeah, because I think I did something wrong. I needed to choose it to the high, because it is not that every time, because high can be anything else. Yeah, I have to use this high. So let me just use this odd of high. Yeah, I think I did something wrong. So this is why we're gonna check by function instead of the whole program. Yeah. So here gonna be the order of high plus 1, and I want to find this character. So the character gonna be a character. We're gonna call character of this D. Yeah. So currently we're gonna choose all characters like from A to the high, and then we're gonna turn the numbers to ask numbers to the character, and then we're gonna check the character. If it is less than or equal to the high, we're gonna update it. Now let me just check. Yeah, because my return is not right, so let me give a return. Yeah. Now let's just check what happens for us. So instead of returning 51, we have a return of 79. Let's just check if this 79 is right. Yeah, because currently we didn't include anything about this evil, and we just want to count from characters A, B, C, D. Yeah. So if it is starting with A, how many different characters? It's going to be 26, because after that it's going to be A to Z. And similarly for B and C. And what about character D? So for character D, we can only choose character A, because we cannot choose anything else, because this is controlled by this character A. So this means 26 times 3, it's going to be 78, and plus 1, it's going to be 79. Yeah. So this is exactly what we need, because our output is 79. Yeah. So this is our first step. So we're gonna try to yeah, we're gonna try to write a digit dp function. Now, for our second step is that we're gonna try to write a KMP function. Yeah. So let me put the final return here. Let me just comment the final return. Yeah, because currently I want to write a KMP function. This is what we need. Yeah, because for example, this evil is b. So for example, this evil is AB. Definitely we're gonna have many different characters. So for example, between S1 and S2, we find this AB. How can we avoid this AB? So this is avoid by using the digit dp function. Inside we're gonna avoid it. Yeah. So this is actually a string matching problem. Basically, this AB is gonna match with this AB. Yeah. Maybe the string gonna be very long. So for example, A B C D E A B C D F, and our current evil is A B C D F. Yeah. So what are we gonna do? We're gonna use the string matching to find this A B C D F. If we can find it, so we're gonna avoid it. Yeah. But if you didn't use the KMP, basically it's a brute force. It's gonna be time limit exceeded. Yeah. So this means we have to use the KMP algorithm to find it, because basically this is gonna be O(n) time. Yeah. Instead of O(n) square. Now let's just finish the KMP algorithm for the next table. So this is the next table. We're gonna write the next table and say it's gonna be a -1. There's gonna be a -1, and for I in range the length of the string. So we're gonna use a while loop to check if this z is more than equal to 0 and si not equal to sj. So we're gonna jump for the next table. Z gonna be next to j, and after that z gonna plus equal to 1, and the next table gonna append this j. So finally we're gonna return the next table. Yeah. So for my next table for this KMP algorithm, I prepared a dummy place. It's gonna be a -1. This is just this is just a dummy value, but it's gonna be really easy for us to calculate. As you can see, there's just 6 line of code, and we make it totally right. Otherwise, maybe you're gonna write more than 10 lines of code for this KMP next table. Yeah. So this is why I'm prepared a -1, and similarly, this z gonna equal to next one, -1. Yeah. Now what are we gonna do? We want to check if this next table is right. Yeah. So let me just put this line here. And we want to create for the next table, because I want to check if my KMP function is right or not. So I'm gonna pass S1, and let's just check what happens for S1. Yeah. So this is my S1. So this is a character AA. So for the KMP next table, this is a -1. As I said before, this is just a dummy place. And now we have 0, and now this is a suffix equal to the prefix a. This is suffix with a equal to the prefix a. So this is gonna be a 1. Yeah. So this is exactly what we need. Yeah. So this means our KMP algorithm is also right. Now what are we gonna do? So the third step is that we're gonna combine the digit dp and with KMP. This means we're gonna use the evil. Yeah. Now we're gonna try to use the evil. Yeah. So this means for the digit dp function, basically we need to have another variable. So I'm gonna call it a hit. So this hit means how many characters hit. So for example, this is a character b. If there's nothing, the hit is 0. If there's a character b, so the hit gonna equal to 1. So we're gonna avoid it. So if the evil is ab, currently we have nothing, so the hit is 0. If we have a character a, this means the hit is 1. If we have another character b, so this means the hit is 2. Yeah. So if the hit equal to 2, it means equal to the length of the evil. So this means we've already found a evil. Basically, this means we're gonna avoid it. Yeah. Now let me just put the hit inside. So this is gonna be starting from 0, and here, gonna be 0 as well. But here we need to check if this is inside the S1 or not. So basically we need to check evil not inside S1. So for this one, I'm not sure if you understand about why we're gonna use this kind of a formula. Yeah, let me just make a drawing. Yeah, so for this kind of a formula, basically this means we're gonna find some characters maybe. This is for S2. This is all the characters for S2. Maybe this S2 is DA. It's gonna be something from AA to DA. It's gonna be many. Yeah, and then we're gonna check this function. It's gonna be S1. It maybe have some range from something to S1, but for our case, this S1 is NAAA. Yeah. So this one minus this one is what left behind. Yeah. So what left behind is AA. Yeah. So we're gonna check this AA, and we're gonna check if this evil is not inside. If it is not inside, definitely we're gonna count it as 1. So yeah, if it is inside, yeah, if this evil is not inside, we're gonna count it. If this evil inside, basically we will not count it. So we're gonna set it as 0. Yeah. So this is just some set calculations. Yeah. So in mathematics, this is just some set operations. We just need to avoid that. Yeah. So here we're gonna give an integer. Now we're gonna pass a hit, as I said before. Now we're gonna try to use this hit to finish the final step. I mean the third step for including the evil. So since we are going to include the evil, so we're gonna check the hit. If the hit equal to the length of the evil, so we're gonna return a 0 because this will not be included. Now what are we gonna do? We're gonna check it from here because currently we got a character, and we're gonna check this character equal to the evil or not. For example, if this character equal to the B, we're gonna go to the next step. Yeah. Now we're gonna prepare index J to check how many hits. So this J gonna equal to the hit, and at the same time, let me just copy some code from the next table because basically it's nearly the same. We just need to use some code from the next table to check how many hits. Yeah, you can also use your code if you are writing your KMP. Basically, you just need to copy some code from your KMP, and then you can continue to check it from here. So this means we're going to prepare a variable j. This is going to be the index equal to the hit, and then we're going to check the different cases. Yeah, so if it j is more than or equal to 0, this is not equal, so we're going to jump to the next j. This is for KMP. Otherwise, it's going to plus equal to 1. And finally, if this is j is less than and equal to the high, what are we going to do? We're going to update it to the final result. So it's going to be this is j. We're going to pass it to here. Yeah. Now let me just run it. It didn't work. Yeah, it didn't work. Let me check what is wrong. It's going to be 51, but my output is only 1. Definitely it didn't work. Yeah, because I didn't change it from here, because I just copied it, I needed to change it. So if this character C, because we're going to compare with the evil instead of S. Yeah. If this character C is not equal to the evil J, so for example, if this character C currently is A or C not equal, we're going to use the next table to jump. If it is equal, so for example, it is a B, so this is J gonna plus equal to 1 because J is yeah, let me think about it. Yeah, so if it is equal, so J gonna plus equal to 1, so 0 plus 1 is gonna be 1, and then if this head equal to the length of the evil, this 1 equal to the length of the evil 1, we're gonna return a 0. Yeah. Now let me just run it. Object is not subscribable. I don't know. Yeah, it must be something wrong. Yeah, let me just go back. This is difficult. So currently it is wrong because I didn't check here. Definitely this is wrong. And I want to check this character. If this character is not equal to the eval of z, I'm gonna jump the j to the next j, and j gonna plus 1, and I'm gonna pass it to the final result. Oh, I think it is maybe because of this next table, because I didn't prepare this next table. Yeah, so now let me just do some preparations. So let me just prepare a mod. It's going to be what is given, 10 to the power of 9 plus 7. Yeah, because here currently we didn't prepare the next table. Now let's just prepare the next table. It's going to be the next function, and we're going to put the eval inside. We're going to pass the eval inside, and the final result is this one. Yeah, now let me just run it. Now as you can see, it works. So for the last case it didn't work because we didn't use a mod. So now let me just use a mod. Now finally we're gonna use a mod. So after using this mod, let me just run it. Now as you can see, it can pass for testing cases, and let me submit it. Now as you can see, it passed for all testing cases, and it's pretty fast. It is less than 1 second. Now let's analyze the time complexity first before we summarize what we are doing for this problem. Yeah. So for analyzing the time complexity, we're gonna check this I. So this I gonna be dependent on the length of the string, S1 or S2. This n. Yeah. So now let's just check this n. N gonna be 500. Yeah. So this I gonna be 500. And what about this is limit? It is 2. And the string we don't need to check it because it is fixed. Now we're gonna check this height, and this height gonna be 50 because the length of the height gonna be 50. Yeah. Now let's just check something inside. What are we gonna do? We're gonna check the characters from this 90 to maybe 26 characters. We are not sure, but the maximum is gonna be 26. So we're gonna time 26. Yeah, and inside here, this is basically KMP. So for the KMP, I think we need to. Yeah, I think we just need to time 26 because KMP is basically 26 plus another one, plus the length of the eval is 50. Yeah, so we can use this one. Maybe we can use yeah, let me just think about it. So this is a for loop. We're gonna check all the characters. Yeah, so here this is a KMP. We're gonna use the 26. Yeah, because here we've already calculated for the next table. Basically we will ignore that because we're gonna directly use it. But for here, this is like 26. Here is a while loop, but we can, I think we can ignore it. Basically, yeah, basically we need to time another 50 maybe the length of the eval. Yeah, so now let's just check what's gonna be the final time complexity. Maybe here we're gonna just use a 100. So it is 100 times 100. It is 10 to the power of 4 times 500. It's gonna be 5 times 10 to the power of 6. So this is gonna be the final time complexity. It is 5 times 10 to the power of 6 nearly. So this is why it works. Yeah. So the difficult part is first of all, we're going to write a dizzy BP. This is going to be a hard problem. And secondly, we're going to try to write a KMP. This is another hard problem. And thirdly, we need to combine the two hard problems together, and we need to put something inside the DZDP. So this is going to be another hard problem. Yeah, so definitely this is going to be a really hard problem. Thank you for watching. See you next time.